Assalamu alaikum. So in this problem, we are given two integers in and n. So we have to calculate the number of ordered pairs a comma b that satisfies that these two conditions. First one is a must be in range 1 to n and b must be from 1 to n. And a plus b is a multiple of b into GCD of a comma b. So what does it mean? Here a plus b is a multiple of b into GCD of a and b. So we can write it like this: b into GCD equals 0. So if we want a plus b using b into g, the result will be 0, as a plus b is a multiple of b into GCD. Okay. Now we can see that in this part there is b. So for being a multiple, this part, which means a plus b, needs to be in some form k into b. If it is k into b, only then we can divide it by b. So it must be in form k into b or something like that. So here a must be something, some integer into b. Okay. So it is confirmed that there must be something. Let it is b, b into b, and b is b. Okay. Now from these two, we can see that the GCD will be b. Okay. Now, so GCD is b. We can write the equation as a plus b not. We have seen that GCD is b. So b into b, it is b square equals 0. Okay. Now, as something x mod y equals 0. Uh, for simplicity, we are considering x to be 15, y to be 5 equals 0. What it means? We can write it like this: 15 equals 5 into some integer value. So in this case, it is 3. Every number that is represented by this can also be represented like this. Okay. So this one can be represented as a plus b equals some factor, like it is f into b square. Okay. So what we found is f into b square minus b equals a. So this b goes there, and here it was plus and it will be minus a. Okay. And there was range given. The range of a. So we write this: 1 less than or equals a, less than or equals a, less than or equals n. We have nothing to do with this side. We are only considering this portion for simplicity. Okay. So if b square minus b is less than or equals to n, so what we find is that f is less than or equals n minus b, sorry, plus b divided by b square. Okay. Now, um, for every value of f from 1 till n plus b by b square, we get a valid a. So for every b, this count is added to the answer. Okay, but there is one exception. While calculating this, when we consider b equals 1 and for f equals 1, a becomes, what is it? A is f b square minus b. A becomes f b square minus b, which is 1 into 1 minus 1, which is 0. But if we see the range of a, it must be greater or equal to 1. So this is an invalid answer. So as we have included this using our formula, we must uh, we must not include it, and for this we will calculate all these values, and then we will subtract one from the answer. Okay. So if we see the solution, first of all, the test case was given, and then we take in the value of n and m. Here n is the range of a and m is the range of b. Then we iterate from 1 to m for every b and calculate the desired function that we have seen in this page, n plus b by b square. As we have calculated one extra value, which is where a becomes 0, so we subtract it from answer. Okay, thank you.